The sun is often referred to in astronomical texts as a garden variety star, which is okay because it is fairly common type, although I object to it sometimes because garden sort of implies uninteresting.
We can have energy from the sun that affects our communication systems. It can also affect satellites, space missions. It can cause problems with power grids and things like that.
This is Kitt Peak National Observatory and the National Solar Observatory. This is a pretty sunny site. We're in the southwest, in the middle of a desert, at a fairly high altitude, about 7,000 feet. So we're above much of the atmospheric haze that lies down in the lower desert. This is called the Solar Vacuum Telescope. It's a special telescope to observe only the sun, making a special use of mirrors to produce a stationary image inside an observing room. The actual observing apparatus then consists of a spectromagnetograph, which is a special instrument designed to look at the sun's magnetic field. The magnetic field is probably the fundamental physical mechanism which controls the outer solar atmosphere. It's because it varies and changes that particles become accelerated and that they're directed towards the Earth. The areas of strong field, probably here, here, here. This region in particular is an example of an active region. It's a region that is likely to erupt where large volumes of the sun simply are ejected out into interplanetary space. And that is at the heart of space weather.
Space weather starts at the sun, and the sun's atmosphere explodes off of the sun and it flows out into interplanetary space in all directions at about 1,000,000 miles per hour. And then when that flowing solar wind impacts the Earth's magnetosphere, hits the Earth's magnetic field, some of the solar wind particles and some of that flowing energy get trapped, and when the energy is released, it causes enormous acceleration of particles that give us the radiation belts that impact astronauts and impact satellites. It also generates the aurora borealis that we see, and it drives large electrical currents in the high-latitude ionosphere that can impact power transmission on the ground, pipelines, communications, those sorts of things. And then on top of that, the sun occasionally blasts off these large coronal mass ejections, and when one of those impacts the magnetosphere, it's just like hitting an already stressed system with a very large wallop, and that causes some of the largest space weather activity that we see.
Good morning, Space Weather Operations. This is Ken.
The largest flare was an M2.
That's an incredibly impressive region.
All solar activity does not hit the Earth. CMEs, solar flares. It depends where they originated from on the sun and where we're located in space. Something that's located in the middle of the sun, from there, heading straight toward the Earth would be the most likely direct hit.
Right here, that's the one that has been giving us most of the activity.
The data that the Space Environment Center uses is a collection of ground-based and space-based instruments. The solar forecasts remain moderate to high. M-class flares are likely. Our forecasts, our information, our alerts and watches and warnings go out to a variety of customers. Power companies receive our information. Operations centers that are operating satellites, airlines use our information for radio blackouts. Geologists use our information for checking their instruments before they drill. Our forecasts on the short term are not bad at all. They're actually pretty accurate. Long term, even with the weather forecasts, it's difficult to say things, 3 to 7 days out.
I think the day will come when space weather reports become mainstream in our society and our news broadcasts and our newspapers, because we're certainly using space more and more, and I think we will continue to, and we're relying on it more and more for our economy and for our standard of living. And as we use space and rely on space, space weather information is likely to become more prevalent in our daily lives.
Space Weather Operations, this is Gail.